Radiation is the only mode of heat transfer capable of moving across a void without a physical medium. It travels as electromagnetic waves, which allows the sun's energy to cross the vacuum of space and warm the Earth. When that energy strikes a target, it remains conserved, dividing into as many as 3 distinct paths. This diagram represents that incident heat as Q, the starting point for every thermal interaction. The first path is absorption. Here, the incident heat is captured by the substance, increasing its internal energy. We measure this efficiency as the ratio of absorbed heat to total incident heat, known as absorptive power. The second path involves the rejection of energy. This reflected power represents the portion of heat sent back into the same medium from which it arrived. The final path is transmission, where the radiant energy passes through the body entirely to emerge on the other side. To establish the laws of thermodynamics, physicists required a theoretical baseline, a perfect black body. This ideal object would possess 0 reflectance and 0 transmittance, capturing 100% of all radiation that strikes it. Nature, however, offers no such perfection. Even the most absorbent natural materials, like lampblack, still reflect roughly 1% of the radiation they encounter. Because a perfect absorber does not exist in the natural environment, scientists had to engineer a physical trap capable of simulating total absorption. Ferri solved this problem by manipulating geometry rather than relying on chemical coatings. His design achieved total absorption through the clever arrangement of space. He utilized a hollow enclosure painted black on the inside, with a single tiny hole punctured through its wall. When incident radiation enters the enclosure through this tiny opening, it strikes a wedge-shaped obstruction, ensuring the incoming wave cannot bounce directly back out. Instead, the energy is forced into multiple reflections. With every internal bounce, the dark walls absorb a fraction of the energy until the original wave is completely consumed. In this arrangement, the hole itself functions as the perfect black body. The opening acts as a one-way event horizon for heat, while the surrounding enclosure serves as the trap. Ferri's design proved that achieving total absorption depends more on the structural trap energy falls into than the material of the surface it strikes. A perfect absorber remains thermally active, rather than serving as a static final destination for energy. This is governed by Provost's theory of heat exchange. Prevost established that every object above 0 Kelvin continuously absorbs energy from its surroundings, while simultaneously emitting radiant energy back out. An object's emission rate depends on its temperature and the physical nature of its surface. This leads to a key principle. An object's efficiency in absorbing energy is directly mirrored by its efficiency in emitting it. Because Ferri's black body absorbs 100% of incident radiation, it also possesses the highest possible emitting power, radiating its energy outward at the absolute fastest rate allowed by physics. If a body radiates more than it absorbs, it suffers a net loss of thermal energy and its temperature falls. If it absorbs more than it radiates, its temperature rises. The perfect black body exists as a high-velocity engine of thermal exchange, a system defined by total consumption followed immediately by maximal radiation. This continuous exchange explains why a hot object in a room eventually cools down, while a cold object warms up. Both move toward a state of net thermal balance. This invisible process continues until the temperatures exactly match the surrounding environment, finally reaching the point of thermal equilibrium. While it may appear that the movement of heat has stopped once equilibrium is reached, the internal exchange remains constant. At equilibrium, as shown here, the body radiates energy at the exact same rate it absorbs it. The flow of heat continues, but it is locked in a perfectly symmetrical deadlock. From Ferri's punctured sphere to a cup of coffee on a desk, everything is locked in a relentless trade of radiant energy. This is the underlying mechanism that keeps the universe in balance.